We are finally here. It's time to learn the first pillar of JavaScript, and that is closures. Now, as I said before, these two pillars, I think, give you superpowers if you understand them deeply as a programmer. Now, you think I'm exaggerating here, but hopefully after these few videos, you'll understand why. Especially when it comes to closures, we unlock some really interesting abilities in our programs. So let's learn how to harness their power. We have these things called closures in JavaScript because of two things that we get. One is the fact that in JavaScript, functions are a first-class citizen. And we already talked about that. We know what that is. We can pass functions around like data, like any other type in JavaScript. We also have this idea of lexical scope. That is, the JavaScript engine knows, based on where our code is written, before we even run the code, what variables each function has access to. And closure is simply that, a combination of function and the lexical environment from which it was declared. Closures allow a function to access variables from an enclosing scope or environment, even after it leaves the scope in which it was declared. Sounds pretty confusing, right? And closure is one of the most confusing things, but it's an important topic. So instead of me just talking about it, let me demonstrate with code. Let's say we have a function, a, and then this function will have a variable called grandpa that has the grandpa string inside of it, or assigned to it. And then this function returns another function, so it's a higher order function, and we return function b from here, and function b will have a variable inside of it, remember, function scope, that has father, again, same thing, string of father. And that function has, or returns, a function c, and inside of that function, we have a variable called son that has string son. And finally, through all of that, we return, let's say, a template string, and this template string will return a few things for us. It'll return grandpa, it'll return father, then it'll return son. And let's just add some symbols just to make it look nice. So I've created some functions here. And function A and function B are higher order functions because, well, they return functions. Function C is just a normal function because at the end of the day, we're just returning a piece of string. So let's run this code. If I run A here and I click run, well, it returns function B. That makes sense, right? So I can assign this to a variable and call it again, or I can just invoke the next. So whatever the invocation of A returns, I'm going to call again, which I'm going to call function B. If I run this, I get function C. No surprises there. What if I run function C? If I click run, look at that. I get grandpa, father, son. And if you've been working with JavaScript, this shouldn't surprise you, right? This is the expected behavior. But here's my question. How did son, of all people, remember what grandpa was? I mean, if we call function A here, and let's just say const hour, that's a terrible name. Let's do const 1. Well, we just ran this function. This function was invoked. So the only thing we have remaining is this. Function A got popped off the stack. So what happens when things get popped off the stack? Well, we remove the variable environment, right? So shouldn't let grandpa be garbage collected and thrown away because, well, we removed it from the stack, right? Somehow, son has access to grandpa and also has access to father, even after we call the B function. And this is what closure is. Let's visualize what's happening here. With a closure, and by the way, this little box is going to be our closure. When we run the A function first, well, it pops onto the stack, or it gets pushed onto the stack, and we create a variable environment, right? And this context execution has grandpa as a variable. It would also have parameters here, such as, well, the arguments keyword, but because we haven't given it any other parameters, there's no other variables here, just grandpa. And this grandpa, once we call function A, well, what's going to happen to it? We have the chain here, remember, that gives us a link to the global scope. That means if there were any variables in the global scope or global execution environment, then we might have access to them. But for now, in here, once this gets removed off the stack, it's gone. But grandpa still remains. And that's because grandpa over here goes up into this box of closure. Now, why is that? Because this box over here is technically where the memory heap is, right? It's a bunch of memory. And as soon as we don't need things anymore, well, we need to remove it. However, when the garbage collector comes, sees grandpa, says, there's a closure here. It's in this special closure box. And this closure box, I can't clean up because there's something that is referencing grandpa from inside of it. So the next B function gets called. Again, we add it to the stack. A new variable environment is created, and we have father there. Once we remove father, or once B gets popped off the stack, well, once again, father is being referenced by another function inside of it. So it gets put into this closure box. And then C comes around, finally gets called. And we have son variable here. Now, when we return the statement grandfather, father, son, the C variable environment is going to return and say, all right, let's find out what the grandpa variable is. It's going to look in the variable environment and say, nope, I can't find it. But then now, instead of looking in the global scope or global variable, it looks in this little closure box. It says, hey, do you have grandpa? Yep, I do. Hey, do you have father? Yep, I do. How cool is that? And JavaScript does something unique here, right? The JavaScript engine will make sure that the function has access to all of the variables outside of the function with this closure. That is this little box. So closure is a feature of JavaScript. Let's go back to our function again. Because function C is inside of function A and function B, the JavaScript engine is going to say, all right, I'll create a closure for you. All the variables outside of the C function, I'm going to keep around if C is using it. That is, if we had another variable, let's say let random, and then it's a random number. Well, the JavaScript engine, once B is invoked, isn't going to keep random around because, well, it's going to get garbage collected. Nothing's referencing it. But the JavaScript engine is going to keep anything that's still being referenced by a child function. In this case, C still needs father and grandpa. So it's going to keep it around. And closures are also called lexical scoping. Let's think about that. We've seen that before, right? Lexical scoping. Lexical means where it is written. Scoping is what variable we have access to. So by that definition, that means the JavaScript engine, before we run any code, before we get to line 12 or line 13, already knows which function has access to which variables. Because JavaScript is lexically scoped or statically scoped. It sees during the first phase where it looks through our code and says, oh yeah, I'm going to keep grandpa around. I'm going to keep father around even if it gets called because I'm going to create these scope chains for us. Remember this? We had this little hidden property, scope, that created our scope chains and what we have access to. So that the JavaScript engine, before we run the code, has these little links between the functions. And this works because these values are not on the call stack. Instead, they're on the memory heap, right? And the heap just gets cleaned up by the garbage collection. But the JavaScript engine says, no. We still need some of these variables. So why can we use closures again? That's because of what I just mentioned. We can have functions that return functions as first-class citizens, and we have this idea of lexical scope. Where we write the function matters, not where we call the function or where we invoke the function. Let's look at another example. Let's say I create a function called boo, and boo takes a string, and inside of this function, we're going to return another function that will take name. We'll have another function inside of this that gets returned. This will be name2. And then inside of here, we'll just console.log. Let's say hi. Or actually, let's just console log three things. That is string, name, and name2. And a cleaner way of writing this with arrow functions is to just simply do this. So let's do a const boo equals string, which is an arrow function, which is also going to return a function that finally returns console log. So we can just remove all the brackets just like that and keep it on one line. And because we only have one line here, we don't need any curly brackets. We have console log. So that now, if I run, oops, I do need the bracket. If I run boo with, let's say, hi, well, I get a function. That makes sense. If I run it with Tim, I get another function. If I run it with Becca, I get hi, Tim, Becca. And if you haven't realized why I get so excited about closures and why you should too, is that we can have some hidden powers now. For example, imagine if we just did boo hi. I know this is a terribly named function, but let's say that we have boo string here that equals boo hi. And then let's wait, 5 years. And then do boo string name. And then we're going to call boo string. Now, obviously, I just commented out here. But what I'm showing you here is that when I call boo hi and add it to this variable, let's add a const here and a const here, I could, hypothetically, if the JavaScript engine is running, wait 5 years and then finally call boo string. And boo string, even though it will be off the stack, or the boo function is off the stack, will still remember for me this hi that we gave it 5 years ago. That's because, remember, parameters are treated just like local variables that get stored in variable environments. So I can wait 5 years and hold on to information in memory doesn't get deleted, and I can call it whenever I want. Let's take a break and revisit this idea some more to understand its true power. I'll see you in the next one. Bye-bye.